Hi, this is Mr. Gallagher, and this is the second video from section 2.4 of Algebra 2, Writing Linear Equations. As we talked about in the last video, we're going to be using slope-intercept form, which is y equals mx plus b, where m is the slope of the line and b is the y-intercept. So for example 3a, we're going to write an equation in slope-intercept form for the line that has a slope of negative 3/5 and passes through the point 5, -2. Well, as it says in the example, we're going to use slope-intercept form, so it's a good idea to write that, y equals mx plus b. And we don't have a picture of the line like we did in our last couple of examples, so we have to go with the information that's given. And the only two things we know right now is that we have a slope of negative 3/5 and we have this point 5, -2 that the line is going to pass through. Well, a very important part of slope-intercept form is the slope. That's what the m stands for. So we can actually just plug that value of negative 3/5 in for the m. So y equals negative 3/5 x plus b. Now the only part that we have to figure out is what the y-intercept is. Well, we've used half of our information that's given to us. Now the only thing we have left is this point that we know the line passes through, 5, -2. And if you think about what a point is, it's really an ordered pair. It's an x and a y really, where the 5 is how far we move across on the x-axis, and the -2 is how far we move on the y-axis. And if you notice in our equation here, we also have an x and a y. So what we're going to do is we're going to substitute in the 5 for x and the -2 for y. And then the only thing that we have that's unknown is the b, so we can just solve this equation for b, and then we'll know our y-intercept. So we have a fraction of negative 3/5, and we're trying to multiply that by 5, and a lot of times that's not very easy for people to think about. So I'm going to write 5 in a different way. I'm going to put it as 5 over 1. So now what we can do is we can just multiply straight across. We'll have, I'll put the negative with the 3, so it'll be negative 3 times 5 over 5 times 1. And so that becomes negative 15 over 5. And then that actually simplifies kind of nicely to negative 3. And so then there's just one more step where we'll add 3 to both sides. And then we'll have a value of 1 for b. So now that we know our slope of negative 3/5 and we know our y-intercept of 1, we can write our final answer, y equals negative 3/5 x plus 1. Well, there's actually an alternate form of a linear equation that we're going to use, and we can use it in a very similar way to how we used slope-intercept form. Now this is called point-slope form. And there's a little bit more going on. You see we have two y's and two x's, and then we have the m. Well, in this case, the m also means the slope, just like it did in slope-intercept form. But now instead of having a b, which was our y-intercept, we have this x1 and y1, which stand for some point on the line, the coordinates of some point on the line. It doesn't have to be the y-intercept, it could be a point anywhere. So in some cases, that'll actually be more convenient because you have a lot of freedom as to what point you could be dealing with. It doesn't have to be the y-intercept. So I'm actually going to show the exact same example that we did just before, but instead of using slope-intercept form to start, I'm going to use point-slope form. Now at the end of our problem, we're still going to get slope-intercept form as our answer, but we'll use point-slope form to get there. So, as I said before, the m still stands for slope, and we know the slope that's given to us in the beginning, so we can put that negative 3/5 in for m. And then we have this other point here, 5, -2, that we used before. Now in our last example, we plugged in the 5 for x and the -2 for y. But now what we're going to do is we're going to use x1 and y1 as our variables to plug in for. So in our example here, what I'm going to do is I'm going to put the 5 in for x1, so we're subtracting, and then there's the 5 in for x1, and then the -2, which is y1, goes in. You have to be a little careful because we have minus -2. So a lot of people accidentally just write it as y minus 2, but when you begin to simplify, then it actually becomes y plus 2 because we're subtracting a negative. Over here on the inside the parentheses with the x, we'll just have x minus 5. What we're going to do then is just simplify this equation, and when we first we'll have to deal with the parentheses and this -3/5 that's in front. So I'm going to actually distribute the -3/5 to the x and to the -5. So -3/5 times x gets us -3/5 x, and -3/5 times -5, that gets positive 15 over 5, which, as we saw in the last example, that'll simplify kind of nicely to just positive 3. And then one final step, we have y plus 2 on the left side, and in order to be in slope-intercept form at the end, we want to have y all by itself. So we'll subtract 2 from both sides, and then what we end up getting is y equals -3/5 x plus 1. And if you remember from the last example, that's the same thing that we got at the end. So whichever form you want to use, slope-intercept or point slope, they should both accomplish the same thing by the end of the problem. One final example we're going to do here, similar to the last two, only this time the directions are: what is an equation of the line that passes through point 2, -3 and -3, 7? Well, this time we're not given the slope, so that's the only real difference. Instead of being given a slope and a point, we're given 2 points. Well, you might remember from previous lessons that we actually have a way of finding a slope when you have 2 points. If you know the line will pass through those 2 points, you can use the slope formula and plug in the values for both of our y's and both of our x's. And you just have to establish what's x1 and y1 and what's x2 and y2. And then you plug those values into the slope formula. All right, and so of course be careful. I use parentheses when I substitute, so my y2 is 7, and then y1 is -3, so 7 minus -3 is what's up top, and then our x1 is -3 minus a positive 2. So then you'll clean that up a little bit. Up top we're actually adding 7 plus 3, and then on the bottom I think of it as an addition problem too, only we're adding 2 negative numbers. And then you end up with 10 over -5, and then that simplifies just to -2. So now we found a slope. And now we can really proceed just like we did in the last couple of examples. We have the slope, and we don't only have 1 point, we now have 2 points that the line passes through, so we can actually choose whichever one to use. So I'll use point slope form again. And remember, we could have used slope intercept form like the first example, but I'll use point slope, and we'll plug in the things we know. First thing, we found the slope, so we can put that in for m. And we can choose. Now we can use either one of these 2 points. It doesn't matter. They should both get us the same answer at the end. I'll use the ones we have here for x1 and y1. They're a little bit smaller, and it might end up being a little easier. So when I plug in my 2 for x1, and I'll plug in my -3 for y1. Once again, when you start to simplify, be very careful. If you have 2 negatives next to each other, that's going to turn to a positive. And then inside here, it just turns into x minus 2. Then we're going to have to distribute that -2 to both things on the right. So it'll become -2x. And then -2 times -2 is going to get us positive 4. And then just like before, the last thing that we want to do is subtract 3 from both sides to get that y all by itself. And then when you do that, you have slope-intercept form. So the final answer, y equals -2x plus 1.